predominantly hold small helical antennas in a vacuum.
Guess where I am? I'm here at Oxford Space Systems. The reason why I'm here is to visit Mike Lawton. He's an engineer responsible for designing, building and testing deployable satellite antennas. What does that mean? I'm going to find out, and more importantly, I want to know what challenges engineers face when they do just that.
Let me show you antennas that we build here. The Earth is transmitting a whole bunch of radio waves to space all the time. Imagine you are wanting to sail a ship across the Atlantic. There's no way that we're going to pick up a mobile phone signal. The ship would transmit its own signal saying, I'm here, I'm here. We're monitoring how hot it is, what the vibration might look like in there. Tracking signals right through to things like weather monitoring and even earthquake monitoring from space.
So how much bigger would they be in real size?
This is the real size. You're looking at a full-size satellite.
Wow, it's tiny. This bit, you're saying, is the antenna bit?
It doesn't look like this at launch. It is such that it fits in the satellite.
Oh, wow.
And then when we're on orbit, we let it release what we call a deployed antenna.
Oh, okay. Before it gets to its destination, it has to be compact and small.
Space engineering is all about compromise. Depending on the frequency of the radio energy we're using, influences how it responds to the surfaces that it touches. A great example is the microwave oven in your house. You can look inside that oven when it's on, you see the light on, there's the food spinning around cooking.
Yeah.
A whole lot of microwave energy bouncing around, but it reflects off the door that you're looking through. That looks like a mirror to the microwave energy. It can't get through it. So in the same way, if we make an antenna surface behind us, it looks see-through to us, but at the energy, the radio frequency it's working with, it looks like a perfect mirror in the same way your microwave door does.
And this is this material?
This is the antenna surface, yeah. It's metal strands that are finer than a human hair. If we get a little meteorite that goes through it, that hole wouldn't spread. And it's exactly the same knitting pattern we would use on tights.
The fact that these could be ladderless tights?
This is.
Amazing. So I understand that this is the surface, but how do you actually get the structure?
So we achieve the structure by the ribs that you see behind you, these radial lines coming out. And we use a very special type of carbon fiber, a bit like a builder's tape measure, in what we call the deployed configuration.
It's not moving.
But this is special space carbon fiber,
Yeah.
which means it's going to withstand the temperature extremes, the vacuum of space, and this bizarre effect of atomic oxygen, where the last wisps of the atmosphere want to interact and react with materials and damage them. So this would resist this bizarre effect called atomic oxygen.
Unfolded.
Locking into position.
Amazing. And what's this, Mike?
So we spoke about the carbon fiber giving us the backing structure. Well, we can play around with the formulation of that carbon fiber to give us a complete dish on its own. So here is another
Amazing.
parabolic dish.
You're just playing with origami all the time, aren't you, really?
It's origami and smart materials, yeah.
And this, and this, they're all doing the same job of trying to receive or reflect signals, but the difference in the creativity, the innovation is substantial.
It's all about trying to work with the right type of radio frequency energy. They're all trying to solve a specific niche problem, hence their specific niche characteristics.
What is this? Looks like a big box.
It is a big box. It's called a thermal vacuum chamber.
Okay.
And it allows us to make a little bit of space right here on Earth.
A cube of space.
It's a cube of space, yeah. The only thing we can't do is remove gravity. We don't have anti-gravity at the moment. So we can make this 180 degrees, so incredibly hot. But of course, space can also be really cold. If we're on the dark side of the Earth, we're being shadowed, we can get down to minus 150, minus 180.
So is the idea to test? Let's see how our antenna does then.
Indeed. Let's shake and bake.
How did it all begin for you?
Badly or naughtily. So I was left alone. I found a screwdriver, I took the back off the TV and I was prodding around in the back. Managed to electrocute myself and blow myself across the room.
But it didn't put you off engineering?
I thought this was really cool.
Would you recommend engineering to others?
Absolutely.
That was incredible. seeing all these really advanced technologies coming together to create this deployable satellite antenna. It's amazing the amount of innovation and creativity that goes into these things. But what really blows my mind is the fact that all this advanced technology is also in my home. It's in my sock drawer with a pair of tights. Same kind of thing used in the antenna surface. It's builder's tape. It's my microwave. I'm going to be using the same technology tonight to cook my dinner. That is what blows my mind. It was awesome meeting Mike today. I hope you enjoyed it.